In this section, we're going to start looking at fractions in some detail. And what I wanted to do was give you an idea of what fractions represented and what we're talking about when we mean to write them in lowest terms. Let me draw a few pictures to show you what I mean. If I draw a picture like this, the shaded area is 1/2 of the whole. On the other hand, let me draw another picture, similar. This time I've split the region up into 4. And now I've shaded exactly the same amount as the other one, except now you can see that it's 2 out of 4. And these things are equal to each other because they both represent 1/2. Do it again. Here, this one's cut like a pizza, so it's 8 slices. And I will shade 1/2 of the figure again. But this time you can see that it's 4 out of 8 that are shaded. So what do I have here? I have 3 different ways of representing the same fraction. Now, somehow this one here is the most useful to us because it's considered to be in lowest terms. The other ones are not. And I want to introduce you to a simplifying that can happen. Look at 2/4. I can rewrite 2/4 as 1 times 2 over 2 times 2. So now watch what I do. I'm going to put a slice through these two, so I'm going to cancel them, and I'm left with 1/2. So I'm able to go from 2/4 to 1/2 that way. What I essentially did in this picture is by canceling out the 2's like this, I've erased this line. This horizontal line has been erased, and I come back to the original picture. Similarly, if I decide to do 4/8, I can rewrite it. The 4 I could write as 1 times 4, and the 8 I can write as 2 times 4. So you can see I can cancel out the 4's this time. They cancel out, and it would have been like taking this picture on the right and erasing almost all of the lines. Apparently, here I would have erased 1 line and gotten to this. Here I erased 3 lines and gotten to this. So in each case, I can cancel out a given number. So in general, when you see something like this, if I see a fraction that looks like this, or at least one that I can make do this, then I can cancel out the common factor and be left with a simpler fraction. So this is what it means to go into lowest terms. I'm going to do some more examples, and I'm going to get better definitions as I go along, but I sort of want you to feel comfortable with what we're doing before I actually get into the more deep examples. Let's start with 10 over 25. So I want to take it I want to take 10 over 25 and write it in lowest terms. And basically what I want to do is divide out or cancel as many factors as I possibly can. So what I'm going to do is start with the 10 over 25, and I want to look at something that goes into both 10 and 25. So find a number that goes evenly into both 10 and 25. Well, this takes some practice, but I happen to know that besides 1, the number 1 of course goes into anything, the number 5 goes into both 10 and 25. So for example, 5 goes into 10 twice, and 5 goes into 25 5 times. So what I can do is take the fraction and I can factor out a 5 from both the top and bottom of the fraction. Basically, I want to try to factor out the same thing from the top as I do the bottom. So I can cancel out these 5 like this, and I'm left with 2 over 5 as my final answer. So that's what I mean. Now, between the 2 and the 5, there's no number besides 1 that will go into both of those at the same time. So I know that I'm finished. Let's do another example. This time I would like to take 24 over 30 and write it in lowest terms. Before I finish, I think I should have said on the previous one, not that I did anything wrong, but these words were not necessary. And neither was it. I just wanted to write 10 over 25 in lowest terms. The same thing with 24 out of 30. You've got to try to figure out a number that goes into both 24 and 30. So what goes into both 24 and 30? Evenly. Well, let's take a look at some numbers that actually do. I know that 2 goes into 24 12 times, and 2 goes into 30 15 times. So that's one way I could do it. So I can take my 24 over 30, and I can factor it here. I can write the 24 as 12 times 2, and the 30 as 15 times 2. So you can see I can slice off the 2's, and I'm left with 12 over 15. Now look at what you have. Can you find a number that will go into both 12 and 15? Or are we done? Well, the answer is we're not done. Now, 3 can go evenly into both 12 and 15, because 3 goes into 12 4 times, and 3 goes into 15 5 times. So I could take the 12 over 15, and I can write it as, 4 times 3, that would be the 12 is 4 times 3, and then 5 times 3 for the 15. And then I can cancel the 3's, and I'm left with 4 over 5. Now I know that's done, because I know no number goes into both 4 and 5 at the same time except for 1. So this is considered to be in lowest terms. When you can no longer divide out common factors, it is in lowest terms. Now, I'm going to redo the previous one. If I take the 24 over 30, I could have done this all in one step by noticing that I could factor a 6 out of the 24 and a 6 out of the 30, like that. Then I could cancel the 6's, and I arrive at 4/5 this way. So I could do it in a couple of steps, more than one steps, if it's too hard to see right off the bat what you can cancel, or I can do it in one step if I'm a little bit sharper with being able to determine what goes into both the 24 and the 30. While I'm at it, let me write something down here. This top part is referred to as the numerator, and the bottom is the denominator. I want to use these words because I'll use them throughout the discussion, and I just want you to be comfortable with what I'm talking about. So the numerator is on the top, the denominator is on the bottom. All right, let's continue the exercise. This time I want to write 7 over 28 in lowest terms. So now you need to try to come up with some sort of a number that goes into both 7 and 28. Well, 7 you can't break down except for as 7 times 1. However, luckily, it just so happens that 28 is 4 times 7. So you see I have a common factor that I can cancel. And what I'm left with is 1/4. Of course, if you knew that 7 went into 28 anyways, you could do something like this. And you could have used that to get to what I did anyways. So it just depends on how you see it. Now as I go, the examples will get more complicated. This time I would like to write 36 divided by 324 in lowest terms. Now you could do it all at once, or you could do it in pieces. I'm going to choose to do it in pieces. So this is what I'm going to do. I noticed that 2 goes into both of these numbers because they're both even. So if I take and factor out a 2 from the numerator and factor out a 2 from the denominator, I end up with 18 over 162. Am I done? Well, you should see right now you are not done, because if nothing else, the numbers involved are still even numbers. That means the 2 goes into both of the numbers. So I can do the exact same game I did and rewrite the numerator as 9 times 2 and the denominator as 81 times 2, and then cancel out the 2's. And that will leave me with 9 divided by 81. Now at this stage, this is something you should recognize from when you first learned the multiplication table years ago. And that is that 9 times 9 is equal to 81. So I know that the top can be 1 times 9 and the bottom can be 9 times 9. We slice them out and we are left with 1/9. And that, whenever you get a numerator that has 1, you're done no matter what, because there's nothing other than 1 that's going to go into 1. So what I've circled here is the answer in lowest terms. Now I want to show you how I'm going to redo that example, but the way that I might do it on the board in class, and it would look like this. I would start with 36 over 324, and what I'd write is this. I would put a slice through the 36 and put an 18. I'd put a slice through the 324 and put 162, and it would be expected that the student would know that I just divided out 2 from the numerator and denominator. And then you could do the same thing again. I can take out a 2 from the 18, leaving a 9. I could take a 2 from the 162, leaving 81. And then on my last step here, I know that 9 goes into 9 and 9 goes into 81. So you can see it looks like a lot less effort by just slicing as I go. And so that's generally the way that I'm going to do these things when it's really simple. However, sometimes they get really, really complicated, and it's even more work than what I've just shown here. More examples. This time I want to write 205 over 615 in lowest terms. So let me go ahead and do the way I was just doing. Now notice it's pretty easy to tell that 5 goes into both 205 and 615. How do I know that? Because they end in 5s. If a number ends in 5 or 0, you know 5 goes into it. So what I'm going to do is cancel a 5 into the 205, and so off to the side I may do something like this. I happen to know that it goes into 205 41 times. And then 5 goes into 615. Let me put the 1, then a 2, and then a 3. So by this, you're supposed to understand that I divided by 5. And we end up with 41 divided by 123. Now we're kind of stuck here because 41, in case you didn't know it, is a prime number. That means nothing except for 1 in itself is going to go into 41 evenly. So I can't do anything with 41. All I can hope for is that 41 goes into 123, and then I can simplify that way. So if I try, well, there's not much here that helps me either, because 41 doesn't go into 1, 41 doesn't go into 2, but does it go into 123? 41 doesn't go into 1, 41 doesn't go into 12, does it go into 123? Well, by this, you are going to have to do some trial and error, I'm suspecting, and notice that it goes into it 3 times. So, in fact, this equals 1, let me put a slice through this. So, in my slices this time, I went and canceled out 41 from the numerator and denominator. Now, let me redo the previous example. With factor trees. So what we look at here is still 205 over 615, except I'm going to try to break the 205 up into its factors. I'll show you what I'm talking about. When I do 205, let's see here. I know that 5 goes into the number since it ends in a 5, so I'm going to break it up into 5 times 41. The 41 I can't break up. So what I know is that the 205 is equal to 5 times 41. In fact, I usually circle these things because if you can't break them down any farther, they're prime numbers. The same goes with the 615. I know that 5 goes into it, and 5 is a prime number. Nothing can go into 5 except 1 and 5. And if I divide 5 into that, I know I get 123. The question is 123 a prime number? It's not. One of the tricks that you can learn about numbers is to take the digits and add them up. Here, if I take 1 plus 2 plus 3, that equals 6. And 3 divides, that should be an I, evenly into 6. So 3 goes into 123. That's a trick. If 3 happens to go into the sum of the digits, 3 goes into the original number. So I know that 3 goes into 123. And if you do the division, you'll get 3 and 41. So 615, look at the circled numbers, equals 5 times 3 times 41. Then when I go to do this fraction, I can replace the numerator with 5 times 41, and I can replace the denominator with 5 times 3 times 41. Then all I have to do is look at the factors that are the same in the numerator and denominator and cancel them. For instance, I see a 5 and I see a 5, so I can cancel them. I see a 41 and I see a 41, so I can cancel them. Now notice, it's seemingly I've canceled everything in the numerator. What that means is what I have left is the number 1. In the denominator, the only thing that's not canceled is the number 3. And there you go. So this is an alternative way. If you look at the previous example, I did it in pieces. So I just started cutting it down into smaller pieces, and the same thing goes with the previous problem. I did it in pieces, which most students end up doing. However, some students do go this route and go through the full factorization, especially if the numbers involved look difficult. Finally, if you were really sharp, you could have looked at 205 and 615 and see that 205 goes into 615 3 times. So one last redo looks like this. 205 over 615 equals 205 divided by 3 times 205. I just so happen to know that 205 times 3 is 615. So this would require a lot of capability. And then I can slice off the 205. But when you do that, make sure you leave a 1 so that you don't leave an empty spot where that should have been. So you can do it fast, you can do it slow, or you can do it ultra slow. It just depends. These can be these can be complicated just depending on how big the numbers are. Let me do another example. Let me write 144 over 280 in lowest terms. This time, just to illustrate what I'm doing, I'm going to use factor trees for this. So I'm going to start with 144. Now the way I do it, if you add up the digits 1 plus 4 plus 4, you get 9. And that means that 3 goes in the number. In fact, it means that 9 goes into the number. But I'm going to start even more simple. Since 144 is an even number, I know that 2 goes into it. So I'm going to factor out a 2. Now, how many times does it go into there? Well, you can do a long division or something else, but see that 2 goes into it 72 times. I'm going to circle my 2. Because it's a prime number, I want to keep it. Now 72, I'm going to work that 72. Same thing, I'm going to do it again. I notice that 2 goes into 72 because it's an even number. As long as it's an even number, I'm going to keep dividing 2 into it until I can't do it anymore. So 2 and 36. I'll circle my 2 since it's a prime number. 36 obviously is not, because once again 2 goes into it. I'll circle my 2. And I'm going to keep doing these 2's until I can't anymore. And there we see I'm done with the 2's. So I have a total of 4 2's that are circled. Now 9 is not a prime number because 3 goes into it. And I sort of told you at the beginning that 3 would go into it. It's just so I haven't discovered it until now using this method. Those 3's are prime numbers. They can't be broken down anymore. On the other hand, I'm going to do the 280, and I'm going to factor out a 2, leaving 140. Since 140 is still even, I'm going to factor out a 2 and leave 70. Since 70 is still even, I'm going to factor out a 2 and have 2 times 35. Now the 35 is not even anymore. That means 2 doesn't go into it anymore. However, from your multiplication tables from your younger years, you should recognize that 35 equals 7 times 5. So I'm going to break that down into 5 times 7 and circle those because those are prime numbers. Now, when I do the 144 divided by 280, I'm going to look along the things that made up the 144, I had 1, 2, 3, 4 2's. So I had 2 times 2 times 2 times 2. There's 4 2's. And then I had 2 3's. So the 144 is completely broken down. In fact, what they call that is the prime factorization of 144. For the denominator, let me look along the 280. I have 1, 2, 3 2's, and then a 5, and then a 7. So I have 2 times 2 times 2 times 5 times 7. Now what I'm going to do is start canceling off these prime numbers. I can take out a 2. I can take out another 2. I can take out another 2. I took out 3 2's from the numerator and denominator. However, if you look at what I have left, nothing else will go into, I can't factor out anything else, because while I have a 2, a 3, and a 3 in the numerator, I do not have a 2 or any 3's in the denominator. So I am left with, in the top, a 2 times 3 times 3, and in the bottom, a 5 times 7. Now when you multiply this out, 2 times 3 times 3 is 18, and 5 times 7, of course, is 35. That's considered to be in lowest terms. Let me come back. When I broke it down all the way like this, I told you this is called the prime factorization. Of 144. On the other hand, when I had 280 was equal to 2 times 2 times 2 times 5 times 7, that's the prime factorization of 280. Basically, you're breaking it down as far as you possibly can, and the only numbers that will be left are prime numbers. One note, some students don't like it broken down quite like that look, and they may write it in the following format. Notice I had 2 times itself 4 times, so we could write it as 2 to the 4th times 3 to the 2nd, and 280 could be written as 2 to the 3rd power times 5 times 7. So these count as prime factorizations as well. They're just a little more compact looking than these upper versions. Both of these are okay. They're both doing the same thing. It's easy for me to tell how many 2's are involved, how many 3's, etc. So there's how we can use the prime factorization to get ourselves a fraction in lowest terms. So write them using the prime factorizations and then cancel the common factors. Now we move on to algebra. That means we're going to start involving letters. I don't know what that's doing there, but we are going to get rid of it. So this time I want to write 3b to the 4th divided by 6b to the 5th in lowest terms. So one way you can think of this is 3b to the 4th over 6b to the 5th. You can think of this as 3 times b times b times b times b. There's 4 b's. And then I can have 6 times 5 b's. And then you can just cancel out the common b's. I have 4 of them between the numerator and denominator. That means I'm left with 1 b in the numerator, in the denominator. The 3 and the 6, I can cancel. A 3 goes into 3 once, but a 3 goes into 6 twice. So there's one way to do it. Or you could do this. Notice that on the numerator, this is 4b's, although it's in compact form, and this is 5b's. So I could do a cancel like this, and notice that I'll leave 1b left over. So that's one way to cancel it. And then when I slice this 3 into 6, I can do it all in one shot, and notice that the only thing remaining in the numerator is a 1, and in the denominator is a 2 and a b. Remember, b is nothing more than what would be a number if I knew it. Let's write 16a to the 5th divided by 56a squared in lowest terms. So I'm going to do like I did just in that last part of the example. And notice in the numerator I have 5 a's up there. There's 5 a's, and there's only 2 a's in the denominator. So when I cancel this, I will leave 3 a's in the numerator. Similarly, I note that 8 goes into both 56 and 16. 8 goes into 16 twice, and 8 goes into 56 7 times. So 8 is the number that I was using to cancel out the 16 and the 56. And when all is said and done, all I have left in the numerator is 2a to the 3rd. And in the denominator, all I really have left is the number 7. And there you go. Let's this time do a negative one. So I have negative 92z to the 6th divided by 76z to the 3rd. And I want to write that in lowest terms. Now the negative actually will be no issue whatsoever. It'll just be part of the answer. There's no way to cancel out a negative unless there's another negative to do it with. And so that negative will simply hang around till the problem is over. Well, the first thing that I see is that I have 6 z's in the numerator. So let me cancel them. I'm a little bit too egregious in what I did. I just want to cancel the exponent. This one I'll cancel all the way because I'm taking those all the way out. 6 minus 3 gives me a 3 up there. So there were 6 z's in the top, 3 z's in the bottom. When you cancel them, you're left with 3 z's. Now between the 92 and 76, you may have to think for a little bit, but I'm going to cancel because I can't think of anything that goes into both of those numbers other than 2. They're both even, so at least I got that. So 2 goes into 92 46 times. 2 goes into 76 38 times. So my negative is still there. I have 46z to the 3rd divided by 38. Now I know I'm not done because 2 still goes into 46 and 2 still goes into 38. So let me cancel into the 46. I'll have a 23 and then I'll have a 19. And so it looks like I have negative 23z to the 3rd power divided by 19. So I avoided writing the z's in longhand. I just decided to work with them in exponential form. So this is the effect of writing numbers or writing fractions in lowest terms. That will be big and very useful for when we start to do things with them. Next, I move on. This section is multiplying and dividing fractions. And I start with multiplication. So suppose I have a fraction, a over b, or a divided by b, however we want to think about it. And I'm multiplying that to another fraction, c over d. The rule that we're going to use for this is you simply multiply the numerators together and you multiply the denominators together. This will be our rule for multiplication. Let me do a quick example and then I'll do more complicated examples after this. Let's start with 2/7 times 5/9. According to this rule that I have up here, I'm going to multiply the numerators together, so the 2 and the 5. I'll write it in steps. I'll do 2 times 5, and in the denominator I will do 7 times 9. And that will equal 2 times 5 is equal to 10. 7 times 9 is equal to 63. Let's do another one. Negative 9/8 times 5 over 12. Now you should know that the answer is negative because a negative times a positive number is negative. So my answer will be negative. So in the numerator I'm going to have 9 times 5. In the denominator I will have 8 times 12. 8 times 12 is 96. And there you go. For this next example, I want to redo I shouldn't say redo the last example. Rewrite that last answer in lowest terms. So I want to take the negative 45 over 96 and simplify it. So we've got to try to come up with some sort of a number that goes into both the 45 and 96, or I have to go with the factor trees. So off the top of my head, if I take the numbers 4 plus 5, I get 9. 4 plus 5 equals 9. That means I know that both 3 and a 9 go into 45. Similarly, 9 plus 6 is equal to 15. And it means that 3 goes into 96 because 3 goes into 15. 9 does not go into 15, so 9 does not go into 96. So let me write this out here. 4 plus 5 equals 9. 9 plus 6 equals 15. 3 and 9 go into 9. 3 goes into 15. So I do know that 3 goes into both the 45 and the 96. And that's it. I don't happen to see anything else that will go into the 15, because if I think of the 15, well, let me write one step here. 15 is equal to 3 times 5, and 32 is equal to 2 to the 5th power. There's no common factor of 3 that I can cancel, and there's no common factor of 5 that I can cancel. This 2 to the 5th is a bit misleading because you might confuse it with that 5 up there. I don't want you to do that. Maybe it'd be easier if I wrote this out like this. Then when you look at it, I only have a 3 and the 5 in the numerator and all 2's in the denominator. I can't simplify anymore. that cannot be simplified. So I am stuck with this is my final answer. And the negative just hung around. It really doesn't have much bearing on anything. Now I'd like to redo, let me go back to this example up here. So I'm going to start with negative 9/8 times 5 over 12. And I want to redo the example and write it in lowest terms. But before I multiply it, look at this. Look here. All you have to do is look between the numerator and denominators. If there's anything that you can cancel, take a look. This 9 right here and this 12. 3 goes into 9 3 times, and 3 goes into 12 4 times. So, before I even multiply it, I can do this problem. I'll have a 3 times 5 will give me 15. 8 times 4 will give me 32. This is going to be the easiest way to do these problems because once you multiply the numbers together, it gets more difficult to see what numbers go into them evenly. However, when they're smaller like this, it's easier to tell what numbers go into all the numbers evenly. So from now on, that's the way I'm going to be doing the rest of the examples. I'll show you how they're written in the book. It goes something like this. It says multiply by first dividing out common factors. So let's take a look. I have 3/4 times 10 over 13. This is the way I proceed. I look at my 3, and I look at the denominator here. Is there anything that goes into both 3 and 4? No. The only things that go into 4 are 2's, so I can't use that. 13's a prime number, so nothing goes into 13, so I can forget about 3 doing any kind of canceling with these numbers in the denominator. Now I'll move on to my next numerator item, and that's a 10. When I look between the 10 and the 4, I can see that a 2 goes into both of them. So I can cancel out a 2 into the 10 and a 2 into the 4. And what that leaves me with is 3/2 times 5 over 13. Now I've already played games with 3, and then notice 3 didn't cancel anything. Let me finish off with 5. Between the 5 and the 2, there's no canceling that can happen. And between the 5 and the 13, there is no canceling that can happen. So I know that it is in lowest terms right now. 3 times 5 is 15. 2 times 13 is 26. So in this way, you can save yourself probably the most time and most effort by trying to do the cancelings before you actually multiply them together. We're going to spend some time doing these. So I'm going to multiply by first dividing out common factors. And let's see what we have. Here I have negative 2/3 and negative 1/8. First of all, you should know that a negative times a negative is a positive number. So whatever I write, I can ignore the negatives. They've already canceled themselves out. So there's one quick canceling that can happen. Next, let me look at the numerators here. I see, now a 1 is already done. No matter what, you can't simplify a 1 down to anything except 1. But the 2, let me take a look at the 2. 2 doesn't go into 3, but 2 does go into 8. If I cancel the 2 with the 8, I'll be left with the 1 in the 2 spot, but a 4 where I canceled the 8. And so I have 1/3 times 1/4. The negatives, as I mentioned, when a negative times a negative is positive, so they went and took care of themselves anyways. And so I'm left with 1/12. 1 times 1 is 1. 3 times 4 is 12. Let's try another one. Here I'm going to have 7/18d times 6d divided by 5. Let's take a look at what goes into what. With the 7 doesn't go into 18, nor does it go into the 5. You don't cancel a number with a letter, so forget about that. 6, however, 6 goes into 18 3 times. So I have that canceling, and D cancels with D. Whatever D is, I don't care. It got canceled. So what am I left with? I'm left with 7/3 times, here notice I got rid of the entire numerator. And so that's 7/15. So even if they started with letters, they didn't have to end that way. Let's do another example. Here I'm going to have 27 t cubed over 7 times negative 14 over 63, well, t cubed. Just because it's looking at me so obviously, I'm going to wipe out the t cubes immediately. They're gone. Now I'll consider the rest of things. Let's look at the 27. When I look down here at the denominator, is there any number that you can think of that goes into both 27 and 7? Well, no. 7's a prime number, and 7 doesn't go into 27. However, 2 plus 7 is 9. That means 9 goes into 27. 6 plus 3 is 9. That means 9 goes into 63. So if I cancel out a 9, I would leave a 3 where the 27 was. If I cancel out a 9, I'll leave a 7 where the 63 was. And there's even more. Look over here, the 14 and the 7. 7 goes into 14 twice. So I can slice this 7, leaving a 1 where it was, slice the 14, and leave a 1 there. Let's gather this all up into our final answer. Notice that I started with a positive times a negative, so the answer is negative. And now let's take a look at what I have left in the numerator. I have a 3 times 1, which is 3. In the denominator, I have a 1 times 7, which is 7. And so I made a mistake, sorry. When I did this slicing here, that was a 2. Hopefully if you were doing this with me, you caught it and were yelling at your screen telling me to fix it. So I've now fixed it. Let me do this numerator again. 3 times 2 is equal to 6. And we get negative 6/7. So this is how they're generally going to look. A lot of cancelings going on before you write the last answer. Now you can do it in slower stages than I do. There's multiple ways of doing these problems, like a lot of the things that we do. But this one then, look at this. 3 fractions. Well, at least they're all positive, so my answer is positive. Now what I'm going to do is start with the 21, and it might be helpful in your mind if you think of the numbers that go into things. The number 10 Well, 21 is 3 times 7, so nothing goes into there. However, here, 10 and 12, they do have numbers in common. 2 goes both into the 10, goes in 5 times, and then 2 goes into the 12 6 times. So I was able to do some simplifying there. And then what about the 15? Well, look at this. 5 goes into the 15, so I can cancel. 5 goes into there 3 times, and 5 goes into 5 once. So this piece is completely done. So whatever happens, I know that I'm going to have 1 over something, and I'll fill in my blanks in a minute. Let me move on to the 11. Is there anything, well, 3 and 7 do not go into 11, and 11 is a prime number, so I can't break it down. 6 doesn't go into 11, and 3 doesn't go into 11. So I know that I'm going to have 11 here. It will not get canceled. 72, though, has a lot of things that go into it. In fact, 7 plus 2 is 9. That means that 9 goes into 72. It also means 3 goes into 72. The reason I mention that is because 3 goes into 21. So the 3 went into 72 24 times, and 3 went into 21 7 times. Now let's take a look at this 24 that's left here. 7 doesn't go into 24, but 6 goes into 24. Look at that. I can cancel. 6 goes into 24 4 times, and 6 takes itself out completely. By the way, once I get to a 1 or something I can't break down any further, I know that I can put it in that spot. This 7 can't be broken down any further. Here, I've got the 4 and I've got the 3, and they obviously don't cancel each other out, so it'll leave a 4 over 3. And now, finally, I can multiply everything out to get my final answer. Notice that nothing in the numerator cancels with anything in the denominator. 1 times 4 times 11 is 44. 7 times 1 times 3 is 21. So that was a pretty rugged example, but you can see there's a lot of canceling that happened there, and it made the final answer very simple. Hopefully you also saw, if you were just to look at this, if I just wrote this out and handed it to you, you probably wouldn't be able to tell what I did. So you've got to listen to all of my descriptions. And when students do this, it gets difficult for me, even for me, to tell what's been canceled. But this is generally the way we do things like that. Now I want to bring up some examples that are odd that you'll encounter, like the following. How do you work something like this? Remember, the goal in all of these problems is to write them in lowest terms. So the easiest thing to do is to rewrite the 40 as 40 divided by 1. That way you've created a fraction out of it, and now I can use my rules to simplify. So for example, I know that 8 goes into 40 5 times. So you're left with 5 over 1 times 7 over 1. You're not going to be able to simplify any farther. And then when I multiply this out, I get 35 over 1. But since it's just 35 divided by 1, we can simply write the answer as 35. Although you will not be deducted credit if you leave it as a 1 in the denominator. But I'll never write my answer that way. I'll write it this way. Let's try 4/9 times negative 72. Here, I have a positive number times a negative number, so we know the result is negative. So at least let me get that down. And then I'm going to think of this as 4/9 times 72 over 1. Now you should know from your multiplication tables that 9 goes into 72 8 times. And so I'm left with a negative as my answer, but I have 4 times 8 is 32 over 1. No big deal there. That's just 32. one last example of these strange ones, and this will look like negative 2 times negative 3 over 8y. A negative times a negative is positive, so I know that I can drop the negatives altogether and rewrite it as such. And now the only thing that I can see to cancel is that the 2 goes into the 8 4 times. And so, well, 1 over 1 is just 1. I can completely ignore that in my answer, but what do I have left? I have a 3 over 4y. So this takes some practice, obviously. Everything, well, you'll be assigned, I don't know, probably 5,000 problems to work until you get comfortable with it. But we've only hit up one part or one half of this section. A second part looks like this. Division of fractions. And you may be worried that what we did might have seemed complicated in this, or maybe not complicated, but you're like, oh great, just as I'm getting comfortable with something, now he's introducing something else. And it's really not so bad. The rule looks like this. If I'm going to divide fractions, I change it to a multiplication problem. This is quite similar to when we took a subtraction problem and turned it into an addition problem. This is really the same thing, but in the realm of multiplication. Notice, though, this second fraction changed from a c over d to a d over c. So I turned it upside down. D over c is the reciprocal of c over d. So basically the way this works is I flip, or I take the reciprocal and I change it to multiplication. I need to give you no more. That's the rule. That's the only rule that there is. And so everything that we've done before can be applied to exactly what we're doing here. So for example, if I have 5/8 divided by 7/4, I will change it to 5/8 times 4 over 7. Now I can do some canceling. 4 goes into 8 twice. I can't do anything with the 5 or the 7. So in the numerator I'm left with 5 times 1, that'll just be 5. And in the denominator I have 2 times 7, that'll be 14. Next, let's do 7/8 divided by negative 21 divided by 10. Same rules for as we have for any other numbers. A positive divided by a negative is negative. So I'm going to put my negative in the front, and I'll just keep it attached to the answer throughout the problem. It doesn't do any more complications than that. I have my 7/8 times, now take the reciprocal of the second fraction, and now I can do some work. For example, I notice that 7 goes into 21 3 times. And then while 8 doesn't go into 10, I do know that 2 goes into 8 and 2 goes into 10. So when I slice this, I'll have a 4 left over and then a 5 left over out of the 10. Don't forget the negative. Now in the numerator there I have 1 times 5 will give me 5. And in the denominator I'll have 4 times 3 will give me 12. Let's try something a little more complicated. Next I have negative 28r squared over 11 divided by negative 32r divided by 33. Now, I have a negative divided by a negative, so the negatives cancel completely. No more negatives in the problem. Now then, I'll drop the negatives and take the reciprocal of the second fraction. Now let's go through and see what cancels with what. Starting with the 28, I can't do anything between the 28 and 11 because 11 doesn't go into 28. However, 32 is a different story. I know that 4 goes into 28 and 4 goes into 32. So I will cancel out a 4 goes into the 28 7 times. 4 goes into 32 8 times. Then I can even do this. R squared and R. I can cancel away that R and take away the exponent because R squared divided by R is just R. I can move on to the 33 and the 11. 11 goes into itself 11 times, but 11 goes into 33 3 times. Let's see what's all left. Notice again the negatives cancel. What do I have in the numerator? I have a 7, I have an R, and I have a 3. So 7 times R times 3 is 21R. In the denominator, I have 1 times 8 is 8. And that finishes the problem. Now for some odd-looking examples that you might encounter. How do we deal with something like this? Once again, it might be best to think of that 15 as 15 over 1, and then this will help you decide what to do. Notice that a negative times a positive is negative, so that negative is not going to go away throughout the whole problem. So that gives me negative 1/3 times 1 over 15. Well then, when I multiply that out, I have my negative. 1 times 1 is 1. 3 times 15 is 45. Whenever you have a 1 anywhere, you know that that fraction is in simplest terms. Sorry, simplest terms means lowest terms. You'll hear simplest terms or lowest terms depending on the class you take. Here's another odd looking one. You'll see something like this: 1/8 divided by 3/5. So this, you should interpret this as 1/8 divided by 3/5, and then you'll know how to handle it. Because now it's 1/8 times 5 over 3. Nothing cancels. Nothing's going to go into that 5, and 5's not going into any of these other things. So I'll get 1 times 5 is 5 over 8 times 3. Well, that's 24. We have 7 over 24 divided by 9 over 16. If you want, you can do this all in one shot. 7 over 24 times 16 over 9. So all I did was skip this step here and go straight to the multiplication. Notice that the 16 over 9 is the reciprocal of the 9 over 16. And then I can do some simplifying. I happen to know that 8 goes into both 24 and 16. And so we have 7 times 2, that's 14. And then 3 times 9 is 27. Look at this one. Negative 18 divided by negative 2/9. This is pretty brutal looking. It's not a fraction over a fraction. You have a number over a fraction. Well, first of all, we have a negative divided by a negative, so the negatives cancel out. So for one thing, I can drop the negatives right off the bat. Now, it's possible that you might want to think of it in this fashion. Think of it as 18 divided by 2/9. Then it may help you to remember to put a 1 underneath of the 18, and that might be useful. And now I'll go ahead and flip the 2/9 to 9/2. And I see that the 2 goes into the 18. And it looks like we're left with just 9 times 9, and that's 81.